Hello, Algebra. We are going to talk about basics of factoring today. It's a very short section, 6.1. We are in chapter 6. Once we are done with chapter 6, we are ready for exam 3. Now, you know that there will be exam 2 redo and probably will be scheduled for this weekend. I am getting this thing done hopefully by the end of the day, so I will be posting announcements. Please make sure you read that stuff. I am trying to post it on Canvas rather than MyMathLab so that we don't have connection issues, right? So to go through exam 2, and then shortly after we'll have exam 3, because exam 3 covers chapters 5 and 6. So I'm hoping that you are keeping current on the material. We only have a couple of sections in chapter 6. I am trying to get real quick and see what are the sections that we have to cover in chapter 6. I believe it's only 3 sections that we need to work. Of course, MyMathLab cannot open the course. What's new? Let's see. Can you open this one? It is really aggravating, or how much. I mean, I understand why, because way too many people are using it. All right, so we have 4 sections, sections 6, 1, 2, 4, and 6. So we have 4 sections to cover. We covered 4 sections in chapter 5, so there will be 8 sections for exam 3. Please keep current work on the homework, and also keep reviewing for exam 2. I'm trying to get it for this weekend, so like 3 days, right? To have it posted that way, because again, and try to get it on Canvas or something like that, so you guys can actually do it. So I'll be posting announcement hopefully by the end of today or tomorrow about it. Let's talk about factoring. So factoring, the word factoring contains the word factor inside, right? The word factor is the inside, and the factor is each one of the numbers, right, that are multiplied into a product. So if I say 3 times 7 equals 21, these guys are factors, and this would be a product. Now, similarly, if I have x plus 2 times x plus 9, which equals to x squared plus 11x plus 18, these guys are factors, and that's the product. So it keeps the same names, even though the thing that we are multiplying are no longer numbers. It's now polynomials, right? In this case, 2 binomials. So you still have factors and you still have a product. Also, if you do distribution, if you say 3x to xy minus 9, right, and you get your 3x squared y minus 27x, these are still factors, and this is still your product. So it doesn't matter, as long as you are multiplying 2 entities, and I'm going to go and say times, and times, right? I'll put that red. So it's clear that you have multiplication of 2 of something, whether they're numbers or polynomials, also distribution through polynomials. As long as you are multiplying 2 quantities, you are having, as long as you're multiplying 2 quantities, you're having factors on the left and the product on the right. So now, factoring. That's the process to to break product into factors, right? So that's what we have. So you're breaking the product into factors. So process to break product into factors. So you are going to start with, I'm just going to give an examples, then we're going to learn how to do it, right? So let me give you an example of 15xy minus 10x, right? And you are supposed to get 5x 3y minus 2. So you see that this is over here a product. That's a product. And these guys over here are factors. Right? So that's what I have for this situation here. So now, how's this done? All right, so let's learn how to factor. If I have 15xy minus 10x, I have to look for common factors. So look for common factors. Look for common factors. And then you are pulling those in front of the parenthesis. Then we take them out in front of the parentheses. So let's break 15 into factors. Well, that's 3 times 5 times x times y. They cannot be broken any further. So you have x, 1x and 1y. Minus, break 10 into factors. That's 2 times 5 and then times x. The word common. Well, 5 is common and x is common. So that is exactly what I put in front as common. And the rest are the leftovers, which is 3y minus 2. And you see that that's exactly what I used to have, right? Your job is to break apart these terms and then factor out whatever is common. Word common means the same, right? Let's take a look at another example of this. So I'm just going to pull a whole bunch of problems that I see in a book, and then we're just gonna go from there. So 8a squared b minus 16ab cubed. What is common in here? Oops. What's common? Well, let's take a look. So 16 and 8. Well, I'm just going to leave it as 8 because 16 can be written as 2 times 8. So I'm going to leave 8. Now 8 should be written as 2. You know what? Let's just factor it all the way. So 8 can be written as 2 times 2 times 2. That's its prime factorization. Right? 2 times 2 is 4 times 2 is 8. You break it down to the simplest possible values, right? Called prime numbers. And you can't break any of these anymore. Then we have two A's and a single B. Minus 16 is going to be 2 and 2 and 2 and 2. Now, how do I get that? Well, you can do it here. When you divide 16 by 2, you get 8. You divide 8 by 2, you get 4. You divide 4 by 2, you get 2. And there you are, 4 2's. You can use this tree approach, which you learned in arithmetic, right, to factor the numbers. So let me do it one more time, if you missed it. 16 is even, so I can divide it by 2. So 16 divided by 2 is 8. 8 is even, I can divide it by 2. So 8 divided by 2 is 4. 4 is even, it can be divided by 2, and we get a 2. So what is at the end branches? We have a 2, 2, 2, and 2. There they are, 4 2's for 16. All right, cool. Now what else is there? So that's 16 broken apart. Then I have 1A and 3 B's. What's common? Let's underline. 3 A's and 3 A's, that's the same in both. We have one of these A's to be the same and one of the B's to be the same. The rest doesn't have its pair, so it's going to be left behind. So what is there? 2 times 2 times 2 times A times B. What are the leftovers? Where only one A stays as a leftover in the first one, and in the second one, so we have a minus sign, and then for the second one we have a 2 and 2 B's left. So now this is 8AB, A minus 2B squared. And these are factors. It's factored out. So now we are learning, right? We are learning factoring, where you get the expression and you are simplifying that expression into factors. Now, this is going to be used later, even in 6.4, I guess, or 6.6. It will be used to solve equations. So, from the point of mathematics and, physics and everything else, this is insanely important, because solving equations and formulas is all we care about, because that's how we build things in the world. That's how we understand economics and medical field and research and everything, right? It's formulas. So, and formulas are these equations, and if they are equal to 0, right, we can solve them as equations. So, but we need them factored, and that's why we deal with factoring. Let's take a look at another case. 6y cubed minus 2y squared. All right, this one is a little bit trickier. You have 2 times 3 to make a 6, and then 3 y's minus 2 and then 2 y's. So now we're asking ourselves, what is common? Well, clearly 2 is common. Clearly 2 y's are common. So I have 2y squared as a common. Y times y is y squared. What's left? What's left is 3y, and here is the killer, minus 1. So if you factor out everything, minus 1 stays behind as a placeholder for the term that went out. You can't just say, oh, we factored everything out, it's 0, because it's not 0, right? When you FOIL back to check, you will see it's wrong. So this is good, right? This is our answer, and we need this minus 1 there. So let me write it in blood. We have minus 1 in the answer because we factored out everything in the second term. We factored out everything. Now, it does make sense. Look, when you multiply back, what do you get? 2 times 3 is 6. Y, 2 plus 1 is 3. And now you have something to multiply this into. And that's negative 2y squared, because it's just times 1. And you get this back, right? If you didn't have minus 1, then you would have nothing to multiply it back into, and you will never be able to retrieve this, which is the second part of the expression up there. So we must have this negative 1, which will generate this term back when we distribute it. Let's take a look at another example of something like this. So say you have 18x cubed y minus 6xy. Since we see this is a 6 and that's 18, we can write 18 as 3 times 6 times xy minus 6xy. So what I have done here is I broke it apart so that I can pull common things. 6 is common, and then xy is common. So 6xy is common, and the leftovers is 3x squared minus 1. Remember, when you factor out everything, you are left with 1 over there. If the problem was plus, then it will be plus 1. Check. 6xy, 3x squared minus 1. It distributes. I get 18x cubed y minus 6xy because I have negative 1 to multiply it back to. Let's take a look at more of this stuff from the homework. Two x to the 4 plus 8x squared. Factor. Well, this is 2 and 4 x's plus 2 times 4 and 2 x's, and then you collect common stuff. 2 is common and 2 of the x's common. So 2x squared is common. What stayed in the first are 2 x's, that's x squared, plus 4. Right, in the second one, both x's are out, number 2 is out, so all it's left is positive 4. It's very systematic, but you need to be able to break it apart. You can have more than 2 terms. 2z cubed plus 8z squared minus 4z. We can have more than 2 terms. So that's 2, cross your z's so it doesn't get confusing. Since we can kick out 2, here we go 2 times 4 and then 2 z's, and minus 2 times 2 with a single z. And you ask yourself what's common. Every one of these has a 2, and every one of these has at least one z. So whatever term has the smallest amount of whatever you're comparing, that is what you get to kick out. So this term has three 2's, right? It has 3 2's, right? Because it's 2 and then times 2 and then times 2. That's how you make 8. But I can't kick more than 1 because this term over here has only 1 2. And we need common. What is the same in every term? So every term has one of the 2's. And that's it. So we can kick out a 2. And then we can kick out one z only, because this term has only one z. You can't kick out more than one z if this term doesn't have enough to kick out, right? So we are left with the z squared on the first, because 2z is remaining. Over here is plus 4z, that's what's remaining. And on the second one, minus 2, because that's what's remaining. So this over here is what's common to kick out, and this is leftovers. And you can do this stuff with entire expressions. Let's say you have a 4x a minus b plus 3x a minus b. So, what is common, you ask yourself, right? For both terms. What is common? Well, a minus b is common. So, a minus b, and then 4x plus 3. These are leftovers. Because once I kick out what's common in both, which is this and this, that's common and that goes here, you see that the leftovers are 4x plus 3. (12a) x plus 6 minus 6 x plus 6. Aha! This term here and this term here, they have 12 and a 6 and they have stuff in common. I see that x plus 6 is common, that's good. But I also the numbers. So I have to break it into 2 times 6 times a x plus 6 minus 6x plus 6. And now when you ask yourself what's common, you get that both of these have a 6 and both of these have the big parenthesis. So 6x plus 6 is the common stuff. And the leftovers are 2a minus 1. Again, minus 1, because we factored everything out, right? We factored everything out, so that minus is that minus there. If it's a plus, it will be a plus. So, when you look at this, right, we got to factor everything out, and then we're left with minus 1. So no matter what you have, if you factor everything out, you have to put minus 1. So that's the first part, where you look for the common stuff and you kick it out. Now for the second part, we have a little bit more complex. It's called factoring by grouping. Factoring by grouping. Word grouping, you know what that means. You make groups. and then you deal with each group. Let's take a look at the example. X cubed plus x squared, plus 2x squared plus 3x plus 6. So we want to factor by grouping. What do I do? Well, I first make groups. Now, sometimes you will have to rearrange the order of terms to make groups. Sometimes you just make groups. So, how I did? Case 1, make groups. Case 2, rearrange, then make groups. In this case, I can just make groups because it's going to work just fine. Here's the group over here and the group over here. What is common in the first one? It's x squared, because this one has 3 x's, this one has 2 x's, but this one also has 2 x's inside. So you kick 2 x's out and you're left with x plus 2. So that will be the first. And then the plus. What's common here is 3. 3. Because both of these terms have a 3 inside. So you factor out 3 and you're left with x plus 2. Now, if you are not comfortable with that yet, it's okay to do it on the side. Right? You have your 3x plus 3 times 2 is 6. You kick out 3 and the leftover is x plus 2. You can always do that on the side until you get comfortable to do those factors. All right, cool. Now, what is common? Well, this and this is common. So I have my x plus 2 and the leftovers are x squared plus 3. A little bit more work, right? Because it contains a couple of the problems that we did in the first half of the lecture. But it's still doable. You just have to be a little bit careful what you assign as a group. Right? Let's see more of these problems. Four y cubed plus 10y squared plus 2y plus 5. So I'm going to group again like this and see what's common. If you need to write these, broken down, go ahead. 4 is 2 times 2 and then 3 y's. 10 is 2 times 5 and then 2 y's. So what is common? 2y squared is common, right? So you see, you use up one of the 2's and then you use 2 of the y's. And what's the leftover? 2y plus 5 is the leftover. Plus, and over here you have 2y plus 5. Hey, that's the same. Nice. So this and this is common. So we can factor it. Factor it means put it in front. And now the leftovers. The leftover over here is 2y squared plus 1 because everything factored. When everything factors, you put either plus or minus 1 depending on which sign you have. So in our case now it's plus 1. And it's factored. Yay! Let's take a look at more of these. So this is when they are trying to trick you because they mess up the order. 6x cubed. What happened here? 6x cubed minus 5 minus 10x minus 3x squared. So what you see here is that the order is not what we are used to, right? We like to start with the highest exponent and they go down term by term. So we are going to rearrange these terms first and then go and factor. So 6x cubed minus 3x squared minus 10x minus 5. So sort terms right, sort terms. That means you go the highest to the lowest exponent. Highest exponent to the lowest exponent. So we have cube, then we have a square, then we have a linear, and then we have a constant at the end. So now I have to put my parentheses. Now this one has a negative over here, and that is a little bit evil. So we're going to put the parentheses like this, and then we're going to put plus in between. This negative belongs to the 10. So you can't put parenthesis here because you cut off its negative sign. So negative belongs to the 10 and you put plus in between two parentheses. All right, so what's now? Let's see. So 6 is 2 times, let's go orange. 2 times 3 and 3x's minus 3 and 2x's. Over here, we're going to have 2 times negative 5 with an x and then a negative 5. So let's factor. What's common? A 3 and 2 of these x's. And the leftovers are 2x minus 1. Minus 1 because everything was factored out, so minus 1. Then you have this red plus from up there. And on the other one, what is common? Well, negative 5 is common. And what's left is, right, so negative 5 is common. And what's left is 2x. And we have minus. Did I copy this right? Because once I take minus 5 out, it stays as plus 1. So it can't factor. Oh, it's plus 3x squared. So that's a plus right there. That's a plus right there. Then that's a plus, and now they match. Okay, good. Phew. I went to the book to see. I copied the problem wrong. So please change all of the signs. There's a plus and a plus and a plus. I'll go through this once I'm done again. All right, cool. So now what's common? Well, this parenthesis is common, so we kick that outside, 2x plus 1, and the leftovers are 3x squared minus 5. Those are the leftovers. I have to go through this problem one more time because I copied the wrong problem. I copied the sign wrong. Alright, so in this problem we are getting a problem that it's not written, right, highest to lowest degree. So it's our job to fix that by sorting the terms highest to lowest exponent. Constant term has the exponent of 0, so that one always goes at the end. So we sorted it and then we placed the parentheses to group, and I told you that the minus sign belongs to 10, so parenthesis has to go such a way that that minus belongs to 10. Now, if you don't have a symbol in between the two parentheses, it means multiplication, but we know it's not multiplication, so we put a plus there to make sure, right, because this plus, when it distributes, it doesn't change anything. So we put the plus in there. Then 6 is 2 times 3, and we have 3 x's on a pile. And then on the other side we have 3x squared. So we have common of 3x squared, because both of these have 3 and 2 x's. When you factor everything out, you get to put plus or minus 1. In this case it's plus 1 because we had the plus throughout. Then the red plus that we put in because of the minus situation is there. And now we ask what's common for the second two. And if you take a look, they both have a negative 5. That's why negative 5 is factored. And then the leftovers of 2x plus 1 go into the next one. Now you're going to say, well, wait, why is it plus 1? Well, remember, it's negative 5 that got pulled. So this negative belongs to the 5 over here. And we can also do the plus in front if you want to. So the negative belongs to the 5, and they as a unit are factored in there. So the leftovers are 2x plus, and then we factored everything. Once you factor out everything, you know you have to put 1 as a placeholder. And now 2x plus 1, 2x plus 1. And we get 2x plus 1, 3x squared minus 5, and that's it. Let's work on another problem that contains these minus signs because they tend to be a little bit trickier. So let's go with 12x cubed minus 18x squared minus 10x plus 15. So minus 12x cubed minus 18x squared minus 10x plus 15. Alright, let's do the grouping. I'm going to group the first two, group the second two, and then put the plus in between. So make sure you're always grouping the minus with the number it belongs to. Now, when you break this apart, both 12 and 8 are divisible by 6. So 2 times 6 and 3 x's minus 3 times 6 and 2 x's. Over here, we're going to have a 10. So that's going to be negative 2 times 5 with a single x plus 3 times 5. All right, let's look for common. 6, 6, and 2 of the x's are common. So 6x squared is common. We kick that out. So that's out. what's the leftover? Leftover is 2x minus 3. See, there's a 2 left, and the x, 1 out of 3 x's is out, right? Minus 3. On the second, and then we have the red plus. And on the second one, we are kicking out 5, and we are left with negative 2x plus 3. Ooh, that hurts. That hurts because, look, it's opposite signs. These are not the same, not yet. But there is a trick that you can, so if you have minus a plus b, you can kick out negative 1 and make it a minus b. So you can change all of the signs by kicking out negative 1. So now it's going to be a negative 5, and this becomes 2x minus 3. Because, again, it changed all the signs. A was negative, now it's positive. The b was positive, now it's negative. So whatever was positive becomes negative, whatever is negative becomes positive when you kick out negative 1. What negative 1 does is just changes all the signs. So we have 2x minus 3 as common. And in here we have 6x squared minus 5. Those are the leftovers. So process of factoring is breaking one expression into multiple factors. It cannot be done all the time, right? You have to have special problems where you can factor. Those of you going to pre-calculus, you're going to devote chapter 2 to factoring polynomials. We're going only to do the simple cases like stuff we've seen today, and then a basic trinomial. So this is 1 out of 4 sections in chapter 6. We have 3 more to go, and we will be ready for exam 3 after that one. So I would say we will definitely be done next week. So maybe the following week you could be thinking about exam 3 on chapters 5 and 6. So please practice this stuff as much as possible. Every day is ideal. Short bursts, right? 30 minutes to an hour each day, or do 2 hours, 5 days a week or something like that. Make sure you're putting enough time into this, especially now that, we are not meeting and, the class is online. We are forced to have it that way. So, unfortunately, this is it. Watch and rewatch these videos and try to write these examples. You will be learning if you are writing. Don't just passively watch this with popcorn. You should do that for the evening with the family, since we're all stuck in the house. So just play these videos, binge it every night. So that's it for 6.1 for basics of factoring. Please keep checking for notifications for the exam 2 redo. We have to redo it across the board because half of you couldn't log in to my MATLAB. Some of you were kicked off halfway through, and many of you send the videos and pictures as a proof that that's happening. And I know it was happening because it was happening on my end as well, as I was trying to manage other classes. So I'm working out the workaround, right? The second option, and I will be posting in announcements. So please make sure you log on and read those announcements and post in announcements, and we'll go from there. Bye.